Women in Big Data event. Our today's event is about Google platform, deep dive into IoT on Google Cloud platform. But before we start, it's a custom for us to talk about women in big data. So my name is Stella Mashkevich. I'm a member of Women in Big Data Bay Area. Here is my slide with womenInBigData.org. And since you are here, you probably found us there. So women, first of all, Zoom etiquette, I don't know, I can say it, so we are muted. Q&A at the end of presentation, or you can write questions to not panelists, to Shabasti, to the host, and we will follow up with blog, with presentation material and video link posted on Women in Big Data, usually in about a week. So Women in Big Data is a group. It's organization that started as just group of couple people. And the idea was to champion the success of women in big data careers. We try to inspire, to influence with our key partners. We try to connect, create a community of diverse women in big data and analytics. We grow, we try to help to our members to grow, to develop, educate, support women for development of their careers, and we're trying to elevate by providing opportunities for leadership and forum to celebrate our successes. Here is a little slide with women in big data history. So it started in 2015 with 15 members. I think it's Intel first, but then it quickly grew. I joined in 2016, and it was back then already 1,500 members organization, but I had no idea we will grow past 16,000 in these 3 years. So right now it's past 16,000, and I joined first, came to a couple events, and I quickly realized it's a great community and started to participate actively. So we work with sponsors. This is a list of some of our sponsors. See how many, and this is very good slide that kind of helps pivots, connects to one of our engagements where we do the business series with Regina and others on earning, on negotiation, on career development and others. And this is how we engage with Meetup, with LinkedIn group, and on Twitter, Instagram, YouTube. We have a channel there with videos of our events. So that's the best, to get the most out of this group is to volunteer, because volunteering opens up horizons for you. So our today's speaker is Shrabasti Banerjee, and she's a software engineer with experience in data analytics tools, programming and visualization. She's currently working at Walmart's labs as a big data consultant. She has MBA degree from Indian Institute of Technology, and she worked in a number of companies doing various big data engagements. You can find, there is a link to her LinkedIn profile on Meetup page. So now, Shrabasti, the screen is yours. And you are muted, by the way.
Thank you, Stella, for the nice introduction about women in big data, and for your kind words as well. So I would really like to thank Women in Big Data for giving me this opportunity to share my knowledge and my experience on the big data side with everyone, and see how I can help and contribute. And my purpose is to give the maximum knowledge that I can share during this time from all my experience. So to get started, I wanted to do a deep dive on the industrial IoT, on how the things work on the Google Cloud platform. So here, as we can see, there are different devices. What does the word Internet of Things mean if we try to think about this topic, and how it's related to cloud, coming away from maintaining the infrastructure? We really are going to see how Google helps with the IoT revolution. So if we see here, if we try to troubleshoot what the actual problem is, why is there a need for IoT? So if we see, as you all are already aware, over the media, there are so many different articles and details, and there are so many devices, sensors, which we use every day. And there's been an increasing rise as per different Gartner reports. And it is estimated that in 2020, the amount of devices which will be there will be close to at least 75 billion devices. And in 2030, it's supposed to be 125. So we see that there is an increasing trend in the devices which are being used publicly by everybody. And the areas of usage are different in different areas. For example, it's in the retail domain, being used for the RFID tags, for the security side, the surveillance, the transport, location, geolocations, as well as the manufacturing industry is also having a very big aspect that has led to the need for the IoT. So please feel free to ask me any questions if you have anything, or you can put it in the chat as well. So coming to what is IoT and what is the difference between IoT and IoT. So the difference between the additional I in front of the IoT is how the productivity improvements in terms of efficiency being increased, as well as the productivity being increased. That is the key highlight of the interaction of so many devices which are there, and to ensure that we are able to use the data from all of these devices and gain insights about it, about the data, and improve the processes, being able to predict beforehand maybe a particular breakdown that can be happening in a manufacturing plant, or say even in maybe transport industry. So maybe a particular truck, if there's something which is not working right for the truck, or say even in the medical department, there are so many devices. So for each of the devices, if we see how many the medical, and being able to ensure that we are able to use the data and take preventive, predictive steps, rather than just the firefighting, being able to be proactive. That is one of the major things that IoT is giving us. So coming to the part about how is Google helping in this revolution for IoT. So the Google platform provides a very basic, important thing where one is able to scale up and scale down infrastructure and as needed, and the owners So the persons, you're responsible only for owning the devices that you have. And you do not have to maintain the infrastructure for doing the analytics or getting the value out of the data. And one is also able to perform different kind of machine learning capabilities on the edges, as well as once the data is ingested in cloud. So here for IoT, the thing is, what are the challenges we are trying to solve? If we see that, the main thing is that, there are devices which are there already in the industry outside, and, which might be old dated, say old kind of cameras, which are being used for monitoring on the signals. And the new cameras, which are more advanced, maybe having a higher capabilities in terms of performance. So being able to design a system so that, being able to be responsible for both different kind of devices, as well as ensuring that all the data which is being collected from these devices, sensors, is actually being maintained and we are not losing any data. That is something which is very important. Of course, nowadays, security is a very big aspect, as everybody knows. We have GDPR, which is there in Europe, and it has affected industries as well as the economies all over the world. The way how the companies function, that has totally changed as a result of the security and the compliance. So Google helps to solve this problem using the different tools and technologies. And of course, being able to get the insights from the data, being able to scale up and scale down at, in a second, without having to, plan or prepare anything for it. That is the major advantage. And it's a challenge which Google is helping us solve. Also, how the processes work together, being able to use the technology and the processes, merging them together, getting them to be more effective. That is also a major thing that we want to solve. Does anyone have any questions so far? So going over to the solution for the problem that we are trying to solve, we have different players in the market. Amazon has the Amazon IoT product. Azure, as we know, has also the IoT, as well as Google and IBM. And there are other firms as well that have their own products, which say that they'll be able to implement IoT and support it. And other than these, kind of paid versions options, we also have the option to going to using the open source technologies. So the different kind of open source technologies we can use by ourselves without using any of these platforms are Ka, Siteware, ThingSpeak, different things which are there that we can use if we as an option, if one doesn't want to use to go for Google or Amazon or Azure. So coming to the architecture for the IoT platform, here in the diagram, we can see that how the data is being gathered from the different sources. It could be different, windmills or devices, sensors from the medical perspective, as well as say for the transportation perspective, say cameras which are installed near highways. All these, the data which is coming from all of the devices is being sent to the edge or the gateway. Here, in the edge, the Google has the Google IoT Edge, where one is able to perform machine learning, as well as do preliminary kind of data processing, as well as little bit initial amount of ETL other than on the edge as much as possible. And of course, once the data is being stored on the Google Cloud Storage, then the capabilities and the value one can get out of the data, that is tremendously increased. And the options are also more available. So here we can see there, for example, for performing any machine learning capabilities on the edge, we can have a TPU, attach a TPU, and then do any kind of machine learning analysis we want to do on the edge itself. And at the same time, one is able to, deploy and create and run and ensure that the machine learning models are working appropriately, and tweak and make changes as needed as per the inputs, what is coming from the edge, from the devices. And one thing to be kept in mind here is that the devices are always connected to the cloud, and the cloud knows that which device is active or not active at a particular moment of time. And of course, the IoT piece also includes the processing, where the different capabilities are there, like Cloud PubSub, the DATAFLOW functions, and the way the data is being stored. So one can get the value out of the data in terms of using the Google Cloud Storage, using Bigtable or BigQuery, and then doing machine learning and analytics using Data Studio, the machine learning capabilities which can be applied, getting the insights. All that is a part of the whole big picture. So one of the major things that comes to mind when thinking about the Google Cloud Platform is deciding what kind of tool to use in order to store the data, or get the value out of the data. So based on the kind of the data, whether it's structured, and how much of analytics we are using out of it, and the kind of latency. So accordingly, we can see here that based on whether there are analytics workloads or not, accordingly, one can go for BigQuery or different capabilities like Bigtable. Say if we are designing a system where we need to have a there's a high volume of data which is coming, and it needs to be ingested, and the value needs to be taken out of it, then we'll go for Bigtable. Similarly, based on whether the data is relational or not, accordingly, Cloud GCP provides these products of being able to use Cloud Spanner or Cloud SQL. So accordingly, it is very important during the design to think of what actually is the purpose of the system and the data, and accordingly decide for what kind of data store to use for the purpose. And of course, on the mobile side, application side, whether using Android or iOS, one can go for Firebase or for the cloud storage as well. Now, coming to the part where we are communicating with the devices. So the Google Cloud Platform is getting the inputs from the different devices and using the different connection protocols like MQTT or HTTP, whatever the options are. Accordingly, one can go to opt for it, and accordingly get the data, having the data from the devices as well as the metadata of the device in terms of a proper, each time there's a heartbeat communication that whether the device is actually connected or active or not. So that is also being monitored as a part of the Cloud IoT platform. And here, once the data comes to the Cloud IoT, whatever is coming in, accordingly, it is being sent to the Cloud PubSub, and it can be eventually be stored to the Google Cloud storage accordingly. Oops. So coming to the point of what kind of protocol we are, we can use for the Google Cloud platform, we have MQTT or HTTP we can use, and the piece which is followed for GCP is MQTT, and here the thing is the protocol is in such a way it's working in a pub/sub model. So the client is, which is the data which is coming from the devices, are being published to the broker, are being sent to the broker on a particular topic, and the client can subscribe to any of the topics and receive the message as per their need and inputs. So the thing is, the MQTT provides this capabilities of acknowledgement, whether the kind of acknowledgement can be whether we are sending the data at least once, or at most once, or exactly once. So that helps design the system in a robust way to see how much of data we are retaining, and ensure we are not losing any data. Also here, if we see the kind of the difference, so the MQTT is which is there, and the other option which is there is using the HTTP protocol, which is the 1.1, and it's the older version, so where the acknowledgement requests are not sent, as well as the devices do not maintain a connection to the cloud, so no heartbeat is sent. Whereas in MQTT, the devices each time send a heartbeat to the cloud, that yes, whether they are active or not. So that is also a major piece which is there. And the kind of authentication which is being used is using the different security keys. And so for this particular course which is there in course that I'll be talking about, so from there one is able to do complete the course and do everything in real time. One can get a very good exposure, hands-on, on being able to do all the the kind of streaming, getting the data, doing the encryption as per the packages which have already been provided by Google. So this is one of the very nice factors which are also there, which come in mind. And the more we do, the more we come to know more about it and think about the different aspects. Does anyone have any questions so far? So here also, so for the coming to the point, as we were seeing in the architecture about the IoT core. So here the bridge which is there is automatically, the IoT core automatically plays the part of doing the load balancing, which we do not need to maintain because the Google Cloud is doing it for us. And being able to ensure that the devices are available, connected all the time, and how the devices are controlled, being able to maybe switch off a particular device or sensor if they know beforehand that a particular machinery in the manufacturing side is going to go down, being able to shut it off using the Google Cloud platform. That is one of the very intrinsic and interesting aspects which is there, that helps prevents breakdowns and losses as well. And of course, other than this, so the cloud IoT is using the different highest level of security which is there, being able to know automatically that that every device is available and all the data is being sent to the cloud automatically at every point of time. So coming to the piece that where is the data being stored on the Google Cloud platform? So as you might be already aware, the way the data is being stored is in form of buckets, and there's a limit to the size of the data that you can upload at a particular point of time. And if one, which is the limit of 5 terabytes of data, and if one wants to go around it in case the size of the unstructured data is more or bigger. So accordingly, there are different capabilities which are there. One can play around and do the different development for the personal loading of the data, ensuring it in such a way. So we have the different options of being able to create the buckets and use them as per the need accordingly for files or different kinds of data, whether it's structured or say unstructured data, say images or anything else. And being able to control how the users are able to access that data. That is also a very big aspect role which is there. And using IAM and different kind of capabilities which are there in terms of security authorizations which are there. As a part of that, different keys are there which can be used. So that ways the security aspect is also maintained for the GCS buckets. So as I was mentioning here was there, so the access, the IAM which is there, it controls the access to the data, being able to manage who's able to access the data at a particular point of time, and also whether one is able to just read the data in the bucket or just upload the data to it, or as well as write to the data, being able to change the data which is there programmatically or manually. And there are the different tools, the ways in which whether using the GUI way or the BigQuery console or GSUtil, as well as the API calls, different ways in which one can do the same thing. So as per the use case, accordingly, one has to see and go for the best option that works best for the use case. So one thing which is to be kept in mind here is that there are limits to the bucket creation and the deletion which is there. So initially, when designing the system, proper design has to be there. So accordingly, we can make the best use out of the structured way in which Google stores the data and get value out of the data, functionally as well as technically. So I just wanted to share that this is one of the different kind of storage classes which are there, as we can see here. This is a very visual way, and I found it interesting, where everything is put down, and it shows how the costs being associated based on the different storage classes, and also the kind of content we can go for. Say, for example, for multi-regional, or where we have the maximum availability across all regions, the cost is more, and however, it's much more efficient and more useful for it ensures the highest availability of the data, and it's very useful and very mandatory kind of for the media, video, and as well as the business community. And other than this, of course, there's the regional aspect which is there, where it is not necessary if we do not want the data to be stored across geolocations, say only within a particular area, say across a region in terms of, maybe just in California side. So around that area. So that ways one can do the, it can be useful for use cases for compute and data analytics. And for the nearline, if we are accessing the data only very less frequently, so accordingly then the option of the backup, taking the backups are kind of the nearline, as well as the cold line format is mostly used. And of course the cold line is kind of the cheapest, where one is not accessing. So basically or the way how much you access the data and how much of compute you're doing, when you try to get the value out of the data, that is where the main cost aspect comes from for all the cloud providers. So coming to the different kind of pipelines. So how it works is, once the data is coming to the Google Cloud Platform, one is able to take the data, transform it, do the massaging, do all the kind of ETL ones needs, the extraction, transaction, as well as the loading, being able to enrich the data. One is being able to do the data stitching in terms of being able to, say, combine user data with location data, as well as particular use of a particular product data. So using all this, that's how all the pipelines which are being there used for the Google Cloud Platform, we'll be learning about the different tools and coming to it, the different technologies that GCP offers are cloud functions, as well as cloud data flow templates. And one can customize and write Apache Beam-based SDK pipelines as well. So as we can see here, for once the data is being ingested and coming through the IoT core, it's being accessed into the Google Cloud Platform using the PubSub, storing the data in the BigQuery, or different formats of data, and then being able to do the pipelines, creating the pipelines, and get the value out of the data. That is one of the very big features that is performed here, especially by DATAFLOW. And other than DATAFLOW, which will be coming in future, seeing very soon, we also have the cloud functions, where one is able to write simple code snippets that can be used to run based on a particular event or a particular trigger. One can ensure that the orchestration problems are resolved and not encountered, in terms of being able to do a particular thing at a particular point of time. And of course, other than this, of course, the cloud functions, when one is using them, then of course one is using that, one can ensure that, say for example, based on a temperature, one can turn off a ceiling fan, or based on maybe a particular time, one can ensure that the AC turns on, say if coming back from work or office, if we want the temperature to be a particular time set already before we come in, so the house is cool, accordingly we can set it. So there are different ways and means to do the same kind of things. So coming to the cloud data flow, cloud data flow is the it's a very useful tool which is actually being used for the ETL, and it's used both for batch as well as streaming processes, being able to ingest the data, get the data, doing the transformations, any kind of removing redundant data or removing junk data, getting rid of everything, doing the kind of, maybe say particular in finance, doing particular calculations, being able to do the transformations on the data, and then on top of it, doing the so it can be used for visualization. That's what DATAFLOW helps in, by enriching the data. We can also see that the DATAFLOW, there are many custom templates which Google already provides that one can use. Some of them are like Cloud PubSub or Cloud Storage Decks, being able to store the data in different kind of formats, which are very efficient in terms of being able to retrieve the data and get the value out of it in terms of schema changes, being able to use Avro format. So Google recommends using Avro format. And of course, the recommendations are there, but as per the use case, accordingly, one needs to see what works best as per one's use case. And I wanted to share one of the very interesting, templates which are available. It provides the capability to do compression of the files. So the kind of volume, the way the data is stored in such a way that it's efficient, and also one is able to get the maximum value out of it. So this is very important, that we need to keep in mind that when we are designing applications, that we should be using the compression features which are provided, other than of course the different formats like JSON, CSV, Avro, Parquet, ORC, standard, which is being used in the industry. So coming to what the underlying technology that Google DataFlow uses is Apache Beam based pipelines, where here one is using, just like in Spark, we have different data frames which we are transforming at different points of time and then getting the output. So accordingly here as well, using Apache Beam, one can write custom templates in order to do all the same kind of transformations pipeline as well. Does anyone have any questions so far? So does anyone have any exposure on BigQuery, or what do they think about it?
No one? I definitely don't.
Okay, it's just that I'm not used to so much of talking.
I know.
So if we see here for the BigQuery, the capabilities that BigQuery offers is being able to use the different ETL tools and do the different kind of processing using, say, DATAPREP. Being able to run Hadoop and Spark workloads. So whatever traditionally one is able to implement on the Google Cloud platform. And other than this, of course, being able to use the machine learning capabilities and other different tools in terms of the GIS, as well as the inbuilt machine learning which is available. I'll give you a minute here to just go through this, and I just wanted to share that how this is one of the papers which has been published by the Google, which compares how BigQuery compares with AWS Redshift, as well as the SQL data warehouse and competitors, Snowflake. All these are competitors of Google. So I found this very interesting article, and I wanted to share, which talks about how each of the features work, and also in terms of the cost. So if we see here, as per this, we can see how GCP is providing value over its competitors in terms of AWS and Azure, in terms of being able to in terms of the cost as well as the storage, based on a 3-year model, and also the different kind of, so over a 3-year model, Google is saying that they are providing it at the least cost, and it has a lower total cost of ownership, considering all the aspect in terms of the upfront costs, the infrastructure, as well as the administrative and everything support contrasts which are there. So here, if we see how the different architecture works for all the different AWS as well as Azure and Snowflake, and if we see the infrastructure wise, how is it made up? This shows very clearly, and I'll be sharing this so you would be able to go through it in detail at the end, in convenience as well. So coming to the architecture which is there for the BigQuery architecture which is there, it's based on different, being able to use the Dremel technology, which works on the aspect that one is able to send the data stored in a columnar way, which is very efficient, and also being able to retrieve the data from the different clusters, the different which are there in terms of a tree way, in which it's kind of a trigger where, you know, one query is going and being fetched in a very efficient way. So that's why the time which is being used to get on the on cloud as compared to maybe getting from a particular database, that's in terms of milliseconds, in terms of getting on a huge size of data, say petabytes of data. So that's how BigQuery uses the Dremel as well as the different technologies. On the networking side also, Google uses its own specific tools, as a result of which it is being able to provide this kind of lightning speed for being able to get the data from the different buckets. And other than this, of course, the kind of analytics which is being offered on top of BigQuery is being able to use, being able to share the queries, use them, do the reporting, and the Google Sheets which are there, one can actually use each of the different sheets as kind of different data sources, and then do any kind of ETL in terms of getting the data from the different sheets and doing the summarizations, calculations, aggregations, filtering as needed. We can do that. And once this data is there, Google has a tie-up with its different partners, and it provides the framework, the connectivity to be able to use for different services and industry leaders like Tableau, Power BI, as well as Informatica, Talent, and Looker has also been recently acquired by Google. So all these different capabilities are there. So one thing, one of the major interests here on the GCP is the kind of machine learning capabilities which is allowed on top of it. So one is able to, you know, create models and then predict based on the outcomes of the model, based on the data, being able to predict that. And there are the different kind of algorithms which are available using k-means, clustering, factorization, as well as the TensorFlow models. And one also has the capability to build their own models as per the requirement. So BigQuery also offers this capability where one is able to do, other than the BigQuery machine learning, which it offers on top of BigQuery, it also offers auto ML tables in terms where one can automatically, BigQuery is automatically reading the data and being able to, you know, suggest the best model for the problem. So anyone who doesn't have an idea of, you know, the nitty-gritties of algorithms and data science can accordingly use the capabilities of the AutoML in order to do the machine learning on the data. So that is why the kind of adoption which is there for GCP is really very high, just because of these small kind of things which are also being offered as a part of the big package. So one is able to use, different, use the different kind of skill sets which one might not have, and use them to improve the efficiency of the processes as well as increase the profits. So coming to the cloud data prep. So the data prep is in the background. Data prep uses DATAFLOW, and it uses it in order to clean the data, do any kind of filtering, cleaning, removing the duplicates, anything which is there. And so data prep is a tool which initially it was owned by Trifacta, and Google now is also owning Trifactors and is offering Trifacta in its product in data prep. So in a very visual way, one is able to do the ETL. And I am aware, I was brought to awareness of this because earlier Trifacta, there were limitation in terms of the size of the data you can store and get the value out of it. But with Google Cloud Platform, so now it has become very, you can scale up and scale down as per the needs. So using Trifacta has become very easy and convenient because there are no limitations on the storage aspect anymore. So one is able to, explore the data, do any kind of machine learning and anomaly detection without maintaining the infrastructure. So that is one of the very big aspects which is there. So as we can see here in the bottom, so that's the kind of visualization that DATAPREP offers. So one is able to, access the data and do any kind of visualizations, being able to see it visually, the data distribution in terms of, how many anomalies are there, what are the kind of values which are there. All this kind of distribution, it really helps in, deciding what format, what way does one to go in for the analysis before actually deciding. And one can, play visually around this and see that, applying the different recipes which are there, seeing what works best for the use case. And then accordingly, one can run the job and then save the data in the Google Cloud Storage in the form of tables on BigQuery. Just like in the traditional world, in the data warehouse, we would have tables. So correspondingly, the BigQuery is kind of the data warehouse for the Google Cloud Platform. And the data is data stored in form of data sets, tables, views, and it can all be run. The queries which are there in the BigQuery, it can be run via batch or streaming, different kind of capabilities which are offered by Google. So how the data prep works is one is able to get the data from the source, connect to it, of course. And once connected, one is able to use the different kind of recipes which can be done in terms of visualizations, as we were seeing earlier, and then run the jobs and create the data set in BigQuery. And then accordingly, on top of it, one can have it for reporting and visualization, or any kind of machine learning as well, and on top of that data.
Shabasti, we had a question that came up
Sure.
from Maria. Does
Sure.
BigQuery only work on Google Cloud?
Mm-hmm. So BigQuery is kind of the it's kind of the data warehouse for the Google. So all the data which is stored on the GCS bucket, one can access in terms of data sets and tables which are stored on BigQuery, and then use it it's kind of the SQL interface where one can use for joining the tables, doing any kind of storing the data from the different tables in views, and then views on top of these views, reporting and visualization can be done using Tableau or Looker or Data Studio that Google offers, or any of the other capabilities as well. Thank you for bringing that to attention. I hadn't seen the chat. So
yeah, no worries. Maria, did that answer? Any follow-up?
Yeah, thank you.
Yeah.
Thanks.
Cool. Mm-hmm.
So coming to the aspect for the Data Studio, so it's kind of the dashboarding solution that Google offers in terms of other than what it already, the tie-ups and the connectors it already offers in terms of, being able to use Tableau or say any of the other features. So I just wanted to share this because this was really interesting, how one can use the different connectors using one can connect to the different sources like Big Sheets, BigQuery, Cloud Spanner, Bigtable, and do any kind of analytics on top of it. So there's a whole list of tie-ups that can be done, and one can actually get the use out of the data by experimenting and seeing what works best for one's use case. So using the Data Studio. And so other than this, of course, the Data Studio part, the next aspect, so this was kind of a whole introduction about the Google Cloud Platform using all these different, kind of technologies which are there. The architecture we covered in short, so it was for everything. So here, using all this intrinsic, if you really want to play around with it and see how it works, I would really recommend you to, Coursera has this course on the Google Cloud Platform on IoT, where you can go and, actually get your hands dirty and actually, try out the different features which are there, and there are time limits which are there. So you can actually, use both experiment and create use cases for batch and streaming, being able to, create the devices, do the encryption, creating the JWT tokens, being able to, create the buckets and ensuring one is actually hands-on. One can use the DATAFLOW and the DATAPREP, as well as the visualizations using Data Studio. So seeing that, being able to do everything, it's really very hands-on, and it's not long. It's just a 2-week kind of program that one can just log in and do at one's own pace. And then, one will be really in a more better condition. And, even I'm very thankful to, so Coursera had this link where, I got to learn more about how IoT works on Google Cloud Platform, and I wanted to share this with you all. So that's why I wanted to talk about this, and I would really like to thank Women in Big Data and for all this different kind of opportunities that I have got, different kind of trainings that I have taken and received online. You can go to the training resources at any point of time, and these resources which are there. So, and all of these resources are there for free. So, even if you're maybe giving 15 minutes a day, if you do that for a year, so definitely you would be learning and knowing more than what you know. And of course, other than this, of course, there is, other than the resources, of course, there are the different courses which are there, which are offered by the different partners. And all these courses which are free, it is all free. So you can go in and, do it at any point of time and learn them. So, and it's very interesting at the same time, the different use cases are there which are in big data. So other than this, of course, I would really encourage to you all to, be a part of Women in Big Data and, share any kind of resources you have, be a part of the LinkedIn group we have, and, share your resources. And, of course, as you can help others in need as well. So now I really want to thank you for your time, because it's 7 o'clock and it's the evening after a day of work, or the whole day of work, whether it's at home, whether you're working or not working, it's still the time. So thanks for your time, and I would really look forward to hear any questions or any feedback you have regarding the session.
I have a question. Are you using the BigQuery at work? Is it something that Walmart is using? I don't know. Are you using BigQuery for work, or is just your outside interest?
Okay, yeah, I've been using a BigQuery for past work. I've been working with Palo Alto Networks. Other than the different use cases which I've done initially, when I've been consulting, I've been using for Palo Alto Networks as well as at Walmart.
Thanks.
Cool. And there's another question that came in. Are there ways to apply custom-built ML model on the stored data using BigQuery?
Yeah, there is an option, as I was sharing, right? There are these capabilities which are there on the machine learning side. So, maybe I can just go here and then show around. That will be better. So one can do custom as well as different machine learning capabilities on top of the data which is there in BigQuery, other than the AutoML, which gives the kind of automatic insights. Other than that, one can use all these different models which are there and implement them. And other than this, of course, one can use the TensorFlow models which are there, to actually get the value of the data, do any kind of hands-on capabilities as well. So one is just not restricted. Even if one doesn't know, one can use the AutoML feed capability. And if one does know, then one has the capacity and the option to play around, see the different kind of optimizations and the kind of insights that can be got from the data by using the different kind of models. Does that answer your question?
Hi,
Angela.
Hi, I thought I would just ask directly here. Yeah, thanks for the answer. But I think by custom ML, I kind of was referring more to like a custom algorithm. That if there are to say like if this is like a proprietary algorithm that will need to have it securely hosted and maybe have a separate part of it that's not part of our data processing pipeline. Are there ways to kind of link up the two processes and say like the output of it would not be proprietary anymore and therefore can be readily shared or can be applied to downstream applications? But are there ways to firewall the ML custom ML algorithm?
Yeah. So for the custom ML which is there, you can kind of see. So here these aspects are there, right? You can use any of these models, and other than these models, you can develop your own algorithms using TensorFlow. And then you can use them, and as per whatever the predictions or the data you want to, you can share it with, as per the use case accordingly. And, the thing is, other than this BigQuery machine learning, which you can do on the BigQuery platform, other than this, you can also do it on the edge in the architecture diagram, if you remember, we were seeing, right? So there is the machine learning capability which can be done at the edge itself, where the data is just coming in. So, before doing all kind of processing which is there here. So here, other than the machine learning which is available here, one can do here on the BigQuery side. One can also do the machine learning on the edge. So which is the place where all the data from the devices is coming in initially, and one can do any kind of processing here and kind of filtering the data and running the models here itself on the edge using a TPU if the current thing is not sufficient. Using CPU, GPU, TPU, one can just run any kind of machine learning at the edge and BigQuery, which is the data warehouse.
And then question around, well, Angela, are you good? Did your question get answered?
Thank you.
Okay, cool.
Thanks for the answer.
And then, yeah, Isha, can you share the link to training, which you just shared? That was,
I would be sharing
was that the
slides.
Women in Big Data website, or was it something else?
So for the N1, right? I just went too much. Okay. Okay, now it's ready to scroll.
Isha, go ahead, chime in if you want.
Yes, right now at the end you shared the training where we can get all trainings for Google Cloud.
Yes,
this
yes.
one.
Yes, so this is just the Google link which is there where one can go at any point of time. If you just Google it, it'll come up. And
do you want to maybe quickly put it in the chat?
Sure.
That they, yeah,
yeah, that would be nice.
all the links, yeah.
Chat. Okay, got it.
Thank you.
Welcome. Sure. So this is the one which is the Cloudera one, and of course, for the Google one, you can Google it anytime. Thankfully, we always use Google, so all the time. Sorry. And of course, other than this is the other training program of training details you were interested in. I'll just copy paste it here as well. Oh yeah, BigQuery works on Google Cloud. Yeah, it's just the kind of data warehouse. That's it. Yeah. The thing is, that's what the Google has all these different, tools, technologies, and it has such big things that one can really spend so much time on it and learn so much from it and implement it as well. So there are so many resources which are there. So one can use them accordingly and get value out of it. Yeah, so any more questions? Do we have any questions or any feedback or any kind of observations? If you can share what kind of technologies you're working on and how if you can relate it with Google, I can also help and chime in if you wanted to know something.
Cool, I guess. No questions? Maybe what I was thinking is, since it's a small group, and oh, that's a thank you. Okay, maybe we could do a quick round of intros. Just tell us where do you live and what's your background. Yeah. I can start, or Shrivasti, you can start. You probably people know you already, but
yeah, I think you can start. Yeah. That would be great. We would love to know more about you.
Yeah. And Regina, are you there? Maybe Regina can start.
Yes, I'm here.
Yes. Do you want to quickly introduce yourself? Since it's only 7 of us, maybe spend 5 minutes just
really going. Hi, everybody. I'm the outgoing chapter director. Suchi is the incoming chapter director. Vote. I'm watching the national convention in parallel to this.
Oh, yeah. Well, I definitely have big shoes to fill, and I'm excited to be a part of such a great organization. So Shuchi. I come from the startup world. I've spent about 17, 18 years in Silicon Valley, worked with several startups, ran a couple of my own, and then I was with SAP for a little bit, running their innovation business unit in San Francisco. And then just recently I joined a startup here in the Bay Area. It's called Headspin. And I've been with them for about 4 months. And I'm really looking forward to my time with women in big data. So, and thank you all for joining.
We're lucky to have you.
Yeah, my pleasure.
Thank you, Shuchi.
My pleasure. Okay, I can pick one person. Maria, do you want to go next? And then you can pick the next person.
Sure. So my name is Maria Delarca, and I work as a software engineer. I work at Qubel. It's a startup, and they offer a platform for machine learning, streaming, and analytics. They support multi-cloud, so they have GCP, AWS, and Azure. And
that's interesting.
pretty much it. And